Hello class, today we are going to talk about surface area and volume of pyramids and cones. So in the previous lessons, we talked about surface area and volume of cylinders, and we talked about surface area and volumes of prisms. Today we're going to do pyramids and cones, and we're going to do them both together. So here we go. First, there we go. So, first, a three-dimensional solid with one polygonal base and a triangular lateral faces. That is a pyramid. Right here, we've got some kind of polygon for the base. That just means it has straight sides, and all of the lateral sides faces are triangles. That's a pyramid. If instead you have a circular base with a curved surface, that is a cone. Now, one thing about this, a pyramid, if the base of the pyramid is a regular polygon, so it's a square or a equilateral triangle or regular pentagon, something like that, then we call this a regular pyramid. Now, another thing about this, for it to be a regular pyramid, the apex, this point right here, has to be directly over the center of the base. And the reason we call this a regular pyramid is because all of the lateral faces will be the same size. They'll have the same measurement, and so that's going to make things easy for us. Okay. A cone that has its apex directly above the center of the base, right here, I don't know why it says vertex, that's the apex. This is called a right cone. Obviously, it's not because we have right angles, because there are no right angles on a cone. But what we do have is the thing looks like it's standing up straight. It doesn't look like it's leaning over. The apex is going to be directly above the center. Now, notice on the diagrams here, on both of these, we got the base, we have a height, and then we have a slant height. Okay, so we got the height here and the slant height, also sometimes called the lateral height. Okay, this is the height. If we took this triangle and we laid it flat, that would be the height of the triangle. But now it's leaning over. That is not the same as the height of the cone. Okay, the height of the cone is going to be different. That's going to be straight down from the cone or the pyramid. The height is going to be straight down from the apex, perpendicular to the base. Okay, that's the height. And then here we have the slant height on the outside. All right. So here we go. First, we're going to talk about pyramids. Surface area, lateral area. Remember, that is just the faces, not the bases. So what this is going to be, this is just going to be the area of all of these triangles along the outside. And so one thing we could do is we could just find the area of each triangle and add them up. But there is a formula for this, and this is 1/2 PL. Remember that big capital P, that is perimeter of the base. Now, why would we do the perimeter of the base? We've got these 4 different triangles. They're not even hooked together. It's kind of weird, right? Well, the way this works, if I take all these 4 triangles and I lay them out like this, right? So I could find the area of each one. Well, area of a triangle is 1/2 base times height. So what I end up with is 1/2 the side times the lateral height, because this cursive L, that's the slant height or the lateral height, and that's the height of the triangle on the surface of the pyramid. So I have 1/2 side times slant height, 1/2 side times slant height, 1/2 side times slant height, all with it for all 4 sides, right? For all 4 of the triangles. But then with distributive property, right, we can factor out this 1/2 and the L, and we end up with this 1/2 slant height times S plus S plus S plus S, all the sides added up, and all the sides added up is perimeter. And so we see that's one way to do it. That's where we get this formula 1/2 PL. Now, what if I want the entire surface area? Well, obviously, I just need to add the area of the base, right? I already have the area of the lateral faces, so I just need to find the area of the base and add it in, much like we did with the surface area of a prism. Only in that case, we added in 2 bases. Well, here we're only adding 1. So our formula becomes area of a base plus the lateral area, or area of the base plus 1/2 PL. And the formula for the area of the base, that's going to be different. Depends on here, I've got a rectangle, possibly a square. It looks like a square. Or if I have this one here, now my base is a regular hexagon, and so I have to find the area of the hexagon. Okay, so your formula is going to be different, depends on what shape your base is. Is it a square? Is it a hexagon? Is it a triangle? What do you got? Okay, but you can have the area of the base plus the area of your 4 lateral faces for the lateral area, which is 1/2 PL. All right, so that is that. So here we have lateral area of a cone, and this is a little bit weird. So we have the cone. I have this shape here. The net, it comes out to the sector of a circle, and that's kind of odd. What are we going to do with that? Well, the way we're going to come up with this is we're going to flip back over here to this pyramid. So everybody's comfortable with this net of a pyramid. However, there is another net of these pyramids, and that would look like this. If I take my 4 triangles and put them side by side, or if I take these 6 triangles on the hexagon and put them side by side, I have that. And now we see this looks a lot like a cone, the cone's net, doesn't it? Looks very similar. And so what happens is we end up with the same formula, except instead of being 1/2 perimeter times slant height, what we're going to have is 1/2 circumference times slant height. Now, circumference is 2 pi r. Well, if you want half of 2 pi r, you end up with only 1 pi r. And so our formula becomes pi r slant height. Okay, so we take the slant height times the radius times pi. And that's that. Lateral area. So the total surface area, we just have to add in the area of the circle on the base, which is pi r squared. And so we still have area of the base times plus the slant height, But since it's always going to be a circle with a cone, we end up with pi r squared plus pi r L, where L is not length, L is slant height or lateral height. Okay, or you can think it's the height that's leaning over, which is why we have the L. Okay, so we see really these two formulas are really the same thing. It's just one of them is circle and the other one could be any kind of polygon. So it gets a little bit different. Okay, so that is surface area. Now let's look at volume. So volume of a pyramid and a cone. Now, if this was a prism, it would be area of the base times the height. But it's not a prism, it's a triangle. Well, with triangles, it's going to be a fraction, right? So probably thinking is 1/2 base times height, but no. For volume, it's going to be 1/3 the area of the base times the height. And just like with prisms, Cavalier's principle still kind of works with this. The volume of this pyramid is going to be exactly the same as the volume of this pyramid. We just kind of pushed it over, but we haven't changed the amount of volume in the pyramid. So Cavalier's principle works with pyramids as well for volume, not for surface area, but it does work for volume. Now for a cone, since a cone is really nothing more than a circular pyramid, we're going to have the exact same formula, except for the cone, the area of the base is always going to be a circle, so that's always pi r squared, and so we end up with 1/3 pi r squared times the height. Do notice, for the volume, we are using the actual height, not the slant height, okay? Well, you can remember that. Actual height is going right down the middle. Usually it's going to be inside your pyramid, it's inside your cone, right? Maybe not if it's oblique, but on a right pyramid or a right cone, it's going to be inside the cone. And volume is the stuff you put inside the thing. Whereas slant height, you notice, is going along the surface of the cone. It's going along the surface of the pyramid. And so this is what we're going to use for surface area, is we're going to use the slant height that's on the surface. Okay, so those are our formulas. Here we go. Let's do a couple of examples with this. So example 1. There we go. Find the volume of the figure below. Provide an answer accurate to the nearest hundredth. So let's see what shape we have here. We have a pyramid. We've got a triangular pyramid. It is not a regular pyramid. Notice it's a right triangle down there on the base, but that's fine. That actually makes it easier on us. So volume, our formula for volume of a pyramid is 1/3 area of the base times the height. Well, what shape is our base? It's a triangle. So I need 1/3 times the area of the triangle times the height. Okay, so area of a triangle, that's 1/2 base times height. So that'd be 1/2 times 10 times 11. Remember, base and height are always perpendicular to each other. So that will be the area of the base, and then the height of the pyramid, which is going to be this 12.4 right there in the middle. And so I end up with this. 1/3, then area of my base, 1/2 times 11 times 10 times 12.4. Do we need the 14.9? No, it's just an extra side to give us problems. That's all it is. We don't need that one. We just need these two here that are perpendicular to each other. Base, height. All right. So we take that, type that into our calculator, type it in just like this. I would put the parentheses around it. Not going to matter too much because it's all multiplication division, but it should be okay. And we type that in the calculator, and we end up with, to the nearest hundredth, 227.33 inches cubed. This is volume, and so we do want inches cubed. We'll be in cubic inches. All right, and there it is. Pretty simple. Just take the numbers, plug them into the formula, hit enter. No big deal. Okay, on the next one, we are going to find the surface area of the figure. So not looking at volume, we're looking for surface area. Also, our shape this time, this is a cone. So we want the cone formula, which is going to be pi r squared plus pi r L. Okay, so that is our formula. And so first thing we need to do, let's see, we've got pi. We need to figure out what is r. Well, that's easy enough to do. That's 6 right there. But we want L. And L, remember, this is the slant height. That means it is on the surface of the cone. Is this 8 on the surface of the cone? No, it's not. So what are we going to do with that? Well, I got the 8 and I've got the 6. I've got the height and the radius, and this is a right cone. And so this right here is going to make a right triangle. And if I know two sides of a right triangle, we can just use Pythagorean theorem to get that other side. So my slant height is going to be the square root of 8 squared plus 6 squared, which is 10. And so now I got everything I need to plug into the formula. So pi times r squared, r is 6, and pi times r times L. So we end up with pi times 6 squared plus pi times 6 times 10. And we're just going to plug it all into the calculator just like that. And round it to the nearest hundredth. And we end up with, where did I put it? It's here somewhere. There it is. Maybe. Close to it. There it is. 301.59 meters. We got meters squared because this is area, so it's going to be in square meters. Okay? Doesn't matter if it's area, surface area, lateral area, it's still going to be square units. Okay. So that one was a little bit more complicated because we had to find the lateral height, not just the height. But when we do have that, we'll just use Pythagorean theorem. It's not a big deal. Alright, let's see, what do we got next? Find the surface area of the figure below. So still just surface area. We want answer to the nearest tenth. Now this one is a little tricky because if you'll notice, is this a regular pyramid? It is not. Notice this side of the base is 11, this side is 5. So, and also you notice I have different slant heights. What that means is that lovely formula we have for perimeter, which was 1/2 perimeter times slant height, isn't gonna work because we have a different slant height. We got two different slant heights. So what we're going to do with this one is we're actually going to take this one and we're going to use the net. I'm just going to draw out the net right here. It's not great, but you get the idea. So we got 11 right here. The slant height on the side that has the 11 is 6.3. So that's the height of the triangle when I lay it flat. And over here we have the 5, and that slant height is 8. And what I'm going to do, I'm just going to find the area of all of these different sides and add them up. So first I've got area of a triangle. Well, that's 1/2 base times height. So 1/2, 11 times 6.3, and I have two of those triangles, right? Because these two are the same, so times 2. And I got 69.3. And then we're going to do the other triangle, 1/2 5 times 8, and I got 2 of those, so times 2, and that's going to give me 40. And then the area of the rectangle on the bottom, 11 times 5, which is 55, and we're just going to add that all up, and we get 164.3 square feet, because again, this is surface area. All right, so far, that one's a little bit weird, but we're doing okay. I want y'all to go ahead and do number 4. So pause the video, work out number 4 on your own. We're looking for the volume of a cone. You've got the formula written down on your paper. Actually, you know what? I'll just go ahead and give it to you right there. And come up with the answer. So pause the video, come back when you got your answer and see how you did. All right, you are back. So first thing I'm going to do is I'm going to draw the cone. So there's my cone. It's got a height of 11 yards. It's got a radius of 9 yards. So height and radius, and it is the height, not the slant height, so it's going down the middle, which is good because volume wants the height. And now all we're going to do is we're going to plug in 9 for my radius, and we're going to plug in 11 for my height. And so we have 1/3 pi times 9 squared times 11. Stick that in the calculator, hit enter, and we end up with 933 point, let's see, to the 100th, 0.05 yards squared, cubic yards. Right. So that one was easy. Just plugging numbers in, hitting enter. Okay, let's look at the next ones. What do we got? All right, so we got a paper cup. I want to know what is the minimum amount of paper needed to make the cup and how much water can the cup hold. So this has 2 different parts. If we're looking at the amount of paper needed to make the cup, that is an issue of surface area. So where's my formula for that? I had it somewhere. There we go, surface area. And how much water can the cup hold? That's a question of volume. So here's our formula for that. I want you to pause the video. And actually, hold on. We want surface area of the cup. Does the cup have a top? The cup doesn't have a top, does it? So that means we don't want the total surface area. We just want the lateral surface area. Okay, so it's just going to be the pi r L. Okay, so go ahead and do that and pause the video. Come back when you got your answers. All right, you're back. So here we go. We want pi. We have r. We don't have r. We have diameter. So we don't want diameter. We want the radius. So what do we do with that? Yeah, that's right. We just take that, divide it by 2. And so we have 3.75 and L. Which one is L? Is that going to be the 9 or the 10.5? Yeah. L, that's the slant height, or it's the lateral height. It's the side right here. It's the part that's leaning over. That's the 10.5. So our formula becomes pi times 3.75 times 10.5, which is approximately, to the nearest tenth, 123.7 square centimeters, because this is area. It's lateral area, so square centimeters. Okay, and let's see what y'all did for volume. For volume, we have 1/3 pi r. Remember, r is not the 7.5. R is the 3.75. It's half of that. Times the height, and this is the actual height, not the slant height. So we're not using the 10.5. We're going to use the 9 right here, the actual height of the cup. And so we have 1/3 times pi times 3.75 squared. Do not forget that square, times 9, which is approximately 132.5 cubic centimeters. Cubic centimeters because this is volume. All right, let's take a look at number 6. We are looking for area. Nope. Yep. Total surface area. That's what we're looking at here. So let's see. I'm going to go ahead and give you the formula for that. Pause the video and come back when you have your answer. All right, let's see how you did. So surface area equals area of the base plus 1/2 times perimeter times slant height. Now, this one is a regular pentagon. how are we going to find the area of the regular pentagon? Yeah, it's given to us right there, which is good because finding the area of a regular pentagon is a bit of a pain. But it told us what it is, so we don't have to mess with that. We just have it already, 193.3. So we have 193.3 is the area of the base times 1/2. And then how are we going to get perimeter? Yeah, that's right. We're just going to take this 10.6 times 5 sides. 10.6, 10.6, 10.6, because it's a regular pentagon. All of these sides are the same. All right, so we have 10.6 times 5 is our perimeter, and then the slant height, which is 13. And we just stick that in the calculator, and we get our answer of approximately 422.97. Let's see, this one does not say what to round to, so we'll just go to the 100th. Why not? If you went to the 10th, that's fine. If you went to the 10th, it would be 423.0, because that's going to round this up to 10. It is going to be square inches. Okay. So that one's a little bit different, but that is. So let's take a look. We've got one more, I believe. Yep, there it is. So we want to find the volume of the figure below, provide an answer accurate to the nearest 100th. So I want you to pause the video and work this out. Come back when you have your answer. See how we did. Alrighty, so we're back. We've got volume. And this shape, this is a pyramid, so that means I want the pyramid formula. 1/3 area of the base times the height. And let's see, what shape is our base? Our base is a square. It's 9 by 9. So that means my formula is now 1/3 area of the base would be base times height, right? So 9 times 9 times the height. Which height are we going to use? The 10.6 or the 11.5? Now, this is volume, so that's on the inside of the pyramid, so we want this 10.6 that's on the inside of the pyramid. Remember, this is slant height, that's on the surface, that's for surface area. This is the one we want for volume, 10.6. So we have 1/3 times 9 times 9 times 10.6, and just stick that in the calculator, and we get an answer of 286.20 centimeters cubed to the nearest 100th. And there it is. So just to refresh our formulas here, lateral area of a regular pyramid is 1/2 perimeter times slant height, which is the slant height. It's on the outside. It's leaning over, that one. For the total surface area, it's the area of the base plus that slant height. So plus 1/2 perimeter times slant height, plus that lateral area there. Okay, and that area of the base, that perimeter, that's going to be different depending on which shape your base is. Is it a square? Is it a hexagon? Is it a triangle? What do you got? For a cone, same basic thing. It's just pi r/L, so it's half the circumference times the slant height. And then it's area of the base, which is always going to be a circle, so pi r squared plus pi r/L. Okay, so the surface area of the cone. For the pyramid, for the volume, they are both 1/3 area of the base times the height. It's just that with a cone, the area of the base is pi r squared because it's always a circle. Right? And there you go. That is everything. I hope you found that useful, and I will see you in the next video.